Next topic, derivation of torsional equation. Before that, let's consider the assumptions made in the pure torsion theory of pure torsion. So following assumptions are made for a bar subjected to pure torsion. First one, the material of the shaft is homogeneous or isotropic. The material of the shaft is homogeneous and isotropic, that is, the material of the shaft is uniform and has same modulus of elasticity throughout the shaft length. Second one, normal cross section of the shaft which are plane before twist will remain plane after twist, that is, no wrapping like a paper when twisted, so it will be same after twist also than before twist. It is the cross section, it will not get wrapped. Third one, shear stress is proportional to shear strain, and hence the material of the shaft obeys Hooke's law. So it has to obey Hooke's law before deriving. Fourth one, the twist along the shaft is uniform. So the twist is uniform throughout the length of the shaft. Fifth one, circular sections remain circular. Circular sections remain circular. Thus, all radii which are straight before and after twist. Sixth one, torsion is uniform along the length. Now, derivation of the torsional equations. First one, shear stress produced in a circular shaft. Consider a shaft of diameter d and length L as shown in the figure. So as shown in the figure, so the shaft is attached to one end and has a length L and has a diameter d and is twisted at angles phi and theta. Let L be the length, R is the radius of the shaft, T is the diameter of the shaft, theta is the angle, phi is the shear strain, capital G is the modulus of rigidity, T is the torque that is applied, tau is the shear stress produced. Now, as shown in the figure, in triangle PQQ dash, so shear strain is distortion of the outer surface upon length of the shaft. The shear strain, as you can see from the angle phi, is QQ dash upon the length L, but the arc QQ dash in the second figure, RQQ dash is R theta, because yes, the length of the arc S equals to R theta, so QQ dash is the length of the arc, so it is R theta. So shear strain phi is R theta upon L. Equation 1. Now shear strain phi is R theta by L for equation 2 for any radius. Now this can apply to any radius within the shaft. With Q as the shear stress at any radius, the modulus of rigidity is given by G equals to shear stress by shear strain. that is tau G equals to tau by phi. Equation number 3, G is tau by r theta by L, that is equation number 4. Phi is r theta by L. So tau by r is rearranging, we have tau by r equals to G theta by L equals to small q by r. This is equation number 5. Relation between torque and shear stress continue. Second part. Consider a shaft with a torque T, elementary ring at radius r and thickness dr. Let, as you can see from the figure, it's an elemental ring with radius r and thickness dr. Let r is the radius of the diameter on shaft, T is the torque, Q is the shear stress at any radius r, tau is the maximum shear stress. Therefore, area of elemental ring dA is 2 pi r into dr. 2 pi r is the area circumference into dr is the thickness. We know that tau by r equals to small q by r, or small q equals to tau by r into r, or df by dA. So q is shear stress at any point. So the q is nothing but elemental force by elemental area. So df by dA is tau by r into r. So df equals to tau by r into r into 2 pi r dr, where dA taking d to the other side. So df equals to 2 tau by r 2 pi r square dr. We know that torque is force into distance from the center. So elemental torque dt equals to df into r. So dt is tau upon r 2 pi r square dr into r. Dt equals to 2 pi r cube dr. So total torque T is from 0 to the whole, from center 0 to integration of center 0 to the radius r dt. So 0 to r 2 pi r cube dr. So 2 pi r constant taking out, integrating 0 to r to 4 r cube dr. We have 2 pi r under 2 pi. R cube dr becomes r raised to 4 by r, 0 to r. So 2 pi r raised to 4 by r. So 2 by r, we have pi r raised to 4 by 2 pi 2. Because r raised to 4 is d by 2 raised to 4. It is d by 32 raised to 4. D raised to 4 by 32. So 2 by r pi by 32 d raised to 4. T is j. Pi by 32 d raised to 4 is nothing but j. Polar section modulus j into pi by 2 by r. Polar moment of inertia, that is j. So that is T by j equals to tau by r. So therefore we have the torsional equation T by j equals to tau by r equals G theta by L.